Today, we will learn about Arduino.
What is Arduino? Most simply, it is an affordable microcontroller. Before we move further, let's understand what a microcontroller is. A microcontroller is a small computer chip mounted on a single integrated circuit. It contains memory, programmable input or output peripherals, as well as a processor. A microcontroller is capable of performing multiple operations like input, processing, and output. Most of the computers we are familiar with use a keyboard and mouse to take inputs from the user. An Arduino takes input from the users using various sensors attached to it. These sensors can sense light, sounds, vibrations, and temperature, etc. These microcontrollers can then convert these measurements into digital signals. Humans also perceive their environment using sensors. Similarly, if we attach different sensors with a microcontroller, these sensors can scan the environment around us and store the memory's inputs and process it. The output then can be displayed on a screen. You must have heard of open source softwares. Similarly, there is one more very popular term called physical computing that refers to taking information from the environment, using sensors, processing the inputs and converting it into output.
This clearly means that Arduino makes use of physical computing.
An Arduino can act as the brains of this kind of a system, handling the information coming in and the response going out. The Arduino is part of the open source hardware platform. Under this, experts share their hardware and software solutions. These solutions are available for any kind of modification. Sharing thoughts and ideas with other experts helps in the growth and development of technologies. Okay, let's first start with parts of an Arduino. Built-in LED. The LEDs marked TX and RX show whether your Arduino is sending or receiving data. The one marked is connected to pin 13. On indicator LED. This LED indicates that the Arduino is getting power when it is turned on. Digital input or output pins. The holes on this side of the board are called the digital input or output pins. They are used to either sense the outside world, input, or control lights, sounds, or motors, output. TX or RX pins. Pin 13 and pin 1 are special pins labeled TX and RX. We will cover this in more detail later, but it is good practice to leave these pins empty. Any changes you make to your program won't load if something is plugged into pin 0. Atmega 328P black chip. The black chip in the middle of the board is an Atmega 320P. This is the Arduino's brain. It interprets both the inputs or outputs and the programming code uploaded onto your Arduino. The other components of the board enable us to communicate with this chip when creating projects. Power and ground pins. Pins related to power are located here. We can use these pins to run power from Arduino to the breadboard circuit. These pins take sensor readings in range of values analog. Analog pins. These pins take sensor readings in the range of values analog rather than just sending whether something is just on or off. Okay, now we will talk about connecting your computer to Arduino board. The next important step is to connect your Arduino board to the computer. The following steps show how we can connect the Arduino to the computer. Selecting right components. We need a USB A-B cable, a computer and an Arduino. Plug in USB cable. First plug the USB cable into one of the computer's USB port. Now plug the USB cable into the Arduino USB port. The USB port is labeled. You can see the USB port's top view on the Arduino with the USB A to B cable. After supplying the power LED labeled on, it should light up. And if this is the first time you have plugged it in, the LED on the Arduino pin 13 should blink on and off. Arduino IDE. The Arduino team has designed an IDE for use with their devices with all the features that one may need.
It has a built-in code editor, which is a program used to write any code for Arduino.
The code can be tested in the IDE and can be used to solve any emerging problem with the help of a message area that shows errors in the code and a console that provides more detail about the nature of these errors. It has buttons to check the code, save it, upload it to Arduino and more. Let us understand how to write your first program. Let's now write a code in the Arduino IDE. Different languages can be used for writing code for Arduino like Java, C, C++, and Python. Since we have learned Python in the previous chapters, we will therefore write our code in Python. Before we do that, we need to set the Arduino compiler to communicate with Python and also need to download the Python library. Let's note, before you start writing code in Arduino IDE, make sure your Arduino board is connected to your computer. Follow the steps to establish a connection between Python and Arduino. Step 1. Open Arduino IDE and file. Examples: Fermata, Standard Fermata. Step 2. Now click on the button. This will load the Fermata support files to the Arduino board. Step 3. The next step is to download PyFermata library to Python. This helps to write code for Arduino with Python. Step 4. Type command prompt in the search box and click on the Run as Administrator option. Step 5. Type pip installs PyFermata in the command prompt window and press Enter key. This will start the downloading process. Step 6. Once the downloading process is complete, open the Python IDE and write the following code. Step 7. Press F5 to execute the code. Observe that the LED on pin 13 will start blinking. Let us quickly have a look on chapter Review. An Arduino takes input from the user using various sensors attached to it. Microcontrollers can then convert these measurements into digital signals. The Arduino is part of the open source hardware platform. The on indicator LED is turned on when Arduino is getting power. An Arduino takes input from the user using various sensors attached to it.
An IDE is a software that allows us to write code and test that code out in the programming language.
Arduino has a built-in code editor, which is a program used to write the text files that you create when programming different languages. Can be used for writing code for Arduino like Java, C, C++, and Python.